This video is about knife making, but it starts somewhere else, at my other passions, canoeing and kayaking. When I go kayaking, I have the sense of freedom and adventure, but there is also some risk involved. I love doing it and it's very nice to be out at sea, but when you go over and you can't get up straight, you better have a plan B. This video is about making a kayaking knife. It is the plan B you need to have when you go over and can't always come up. It has been 7 months since I built my last folding knife. But now, here I am again, making my first knife for a customer. And I'm going to use this for it. These are different pieces of lasered and polished jet titanium. And I'm going to show you how to turn these parts into a multi-layer Warncliffe. Well, these are the basic components of the Gersika folding knife. It has 4 titanium shells that are stacked on top of each other, like this. They are held in between by the backspacer, which I have to still make out of titanium. And they all line up like this with the blade. So this is quite a difficult setup, and especially if you want to drill the pivot point. So what I did was make this mold, and you have like the backspacer here. You put it in, and then it's at the perfect position. And the same is for the top layers. Then you have the cover. You can put it together. Then here will be holes for the drilling. There is only one slight problem. My 3D printer and I are not in love anymore, and I have incredible problem with letting the raft go off the print. So we're gonna solve that by using the milling machine, because you can use a milling machine for virtually everything. Let's get to it. Chisel seems to work as well. Then we can place it like that, clamp it and drill the holes. Now that's working, we can start with the most important part where every knife maker starts. The backspacer. I really forgot how much I hated working in titanium. And then this happened. So here we have the part I was making, and here I went too far. I don't know if you can see the lines, but just went too far. So it's almost in 2 pieces. So I'm gonna have to start over, unfortunately. What a terrible material to work with, this titanium. It's absolutely horrible. This is my fire retardant overall. See this here? That's from the Sparks. I'm buying a metal weight for my bed, so I'm done with grinding titanium. I'm really having some troubles with grinding the titanium into shape. You see it right here on top. So what I did is I cheese graded it. Now it's drilled full of holes, and it will mean I have less material to remove, and hopefully I get the spacer quicker into shape. Okay, so I switched over to Cubitron belts from 3M. Works a lot better, really does. Now I have the backspacer. But while the other parts are water jet cut, this part is not. So this is 3D printed with a 0.3 millimeter offset, which is, I don't know, in inches. I'm sorry, millimeters are so much easier. But now I have to fit it inside, so I'm tinkering a bit here and then removing some material there, and then have to go here again, and it makes sure that the final shape is really there, but it also makes fitting it right now a bit hard, which was something I didn't think about. So really have to find a water jet place that does allow to water jet these backspacers for me. The backspacer is inside the mold, and I'm going to lay in the other 2 parts. in place, it's now time to start milling again. And I'm really looking forward to this. I haven't used my mill in this workshop yet. There we have it, assembled with a couple of drills, but always nice to see that first shape. Put in the 3D printed blank for the blade, but we are getting somewhere. So good morning, it's now 7 o'clock. I'm in my workshop already, and this is something I do now every day. I wake up 1 hour earlier so I can start the day with doing the cool stuff. Today we're tapping titanium. It's that time. I was just listening to the Knife Nuts podcast, they were making a joke, and all of a sudden, snap, my tap is gone. I broke my tap. And it's really annoying because it's titanium, so I can put it in ferrochloride and then the edge will actuate the tap, and then tomorrow I can start over. Except the ferrite chloride is in my old workshop, so I don't have it right here. And I'm also going on holiday, so it's gonna take a complete time. Broken drills and taps and reamers are soaking in the ferrochloride. So those metal parts that are inside will be eaten, and the titanium will not be affected by the ferrochloride acid, so that's good. But this is a little novelty I wanted to show you. I was working around my titanium handle parts. There are 4 different parts and they have different thicknesses, but now I have to make final decision which goes where. Does it become a lefty, does it become a right? And I was lost in all the different parts I had. So what I did is I went to my drawbox folder, and there I opened the file I needed to have, and I could match with the XF viewer from Dropbox. I could match the parts together. So now I know exactly which part I'm working on, and I don't have to have my prototypes on hand. Just neat, quick little tip. Very easy and handy. For me, the next step is countersinking these 2 holes for the screws. So I'm drilling it first with a 4mm drill. Then I'm gonna make it a square pocket with an end mill. Then the screw should be flat and countersunk. So the end mill is against the titanium piece. I've marked it on my hand wheel because I don't have any DRO, so I draw a pencil line, so I know exactly 1 rotation of the wheel is 2mm, and 2mm is exactly the depth I need to have. There we have it, the final hole for the screws. Just need to ream it out from the other side, but should be perfect. Final step for now on this handle is drilling a pocket for the pivot pin. I'm gonna do that with this, well, pocket drill I guess it's called, and it goes in like this. It's once again a nice way how to see I use my rotary table and this jig I made for fixturing. So I have 2 clamps and 2 fixing points here as well, and also the drill, it's a bit longer and it centers on the middle of the rotation table as well. So it has 3 points and therefore it won't move, and it's safe to use because I don't have to touch anything at all. For you people to see it. Make a pencil drawing here, make a matching one here, and as I rotate the wheel I can see how far I've gone, and then when I'm on 3/4 of a rotation I can stop, because then it's deep enough. Just like they would do it in the 1950s on this old Swiss mill, but probably they would have made Swiss army knives on them. But this is with the 3D printed backspacer, because the titanium one's still in the asset. But here you can see the knife functioning. You can also see that the entire knife blade is shielded off by the backspacer. So there's no possibility of accidentally poking your finger into the blade. Up first, I'm gonna drill a hole here for the stop pin. Then I go to the open position, drill another hole, which will probably be around here. Then I can mill the stop pin slot. And now I just need to do the same. Then open position. Okay, so I drilled the hole, and the burr in the blade is actually keeping the blade locked right now, which is quite funny. But as you can see, it's not far enough open. I always do this on purpose, because by milling the stop pin track, which will be the oval circle that goes in here, you always remove a bit more material, and before you know it, you're opening it too far. So this is how it's going to be. Would be like a cool tactical knife, I guess. I'm also really liking it with just one layer of scale, but we're going to go for the full package. I really like working with my fixturing setup on my rotary table. I have a lot of space, I can clamp a lot of different things down. There is only one downside. When I started working with a setup like this, I was working with 5mm pivots. Now I'm working with 4.5mm pivots. That means that if I want to mill something in an arc around the central pivot pin, the pivot pin won't fit as tight as it could be. So I made a new one. I'm just going to place it on top of it, ream all these holes, and then we should be able to mill the stop pin slot. That part, stop pin slot. Okay, the new plate is on, and just to show how nice it is, I'm gonna rotate it. So from here to here is 0.05 millimeters, 1/20th of a millimeter. That's great. It means that your surface will be perfectly flat and straight if you mill down and your head is trimmed. I really love this jig. Here. No movement, no play. Tighten it down. Start milling. I've got both frame handles now drilled, this side as well, and all I need is a stop pin. I tried to mill a broken end mill into a stop pin, didn't really work. I think you have to grind them, but I have to do some research. So for now I'm going to make one out of stainless steel. Yes, it's soft, but it's also the knife's going to be used in salt water conditions, so it should be okay for that purpose. So you used to use that lathe, but it's a bit weak. So I'm going to mill turn with my milling machine. Was supposed to be 8mm long, so that's not too shabby, I guess. Here we are right now. I'm gonna end this video, but this is the blade as we now have it. It has an open position, it has a closed position, and it's not smooth yet, but you can wrist flick it. There's actually some tape residue inside the blade, so that's not really helpful, but I think it's really fun build so far. I really like it. It's complex but cool. Yeah, let's keep it at that. Complex but cool. So I hope to see you again next week when I'll try to finish this knife. I still need to do the lockup and the ano, but we'll figure it out. Thank you very much for watching.